Elliot's right, of course, there is no recipe. But I think we do know where the yeast comes from. The yeast that makes the bread, or the gas that fuels the car, and maybe that's the wrong metaphor given the context here in green IT, but I'm going to go with it anyway and play with it for a while. But the fuel clearly comes from the researchers. CCSIP succeeds or not when researchers from California and Canada get together around common interests and determine that it makes sense for them to collaborate. And so by far the most important thing for us to do is to hear the outcomes of the various workshops. So these distinguished panelists have been given that rather daunting challenge of summarizing the day's work in a few minutes. So I'm going to go, actually there's one panelist missing. Where is my infectious diseases representative? There he is. Oh, okay. Well, I was told that you weren't doing this. But John, you're here, so I'm going to let you do it. No? Mixed messages? This is what happens when you bring academics together. I don't know. That one didn't go over that well. So. I am a bit outnumbered here, yes. Okay, John, why don't I give you the first crack at this, though. You'll tell us a little bit about what happened in the infectious diseases workshop, and then whatever's not said we'll turn over to Arthur, is it? Oh, sorry, got it.
There we go.
Now I got it.
I was hoping somebody else would go first to set the standard, but since this microphone doesn't work, it doesn't really matter. Is it working? It's not begun. So let me give you the 10-second summary. From Michel Bergeron, I learned that when I go to my doctor with an infection, my doctor has no idea how to treat me because of improper diagnostics, so he prescribes something. So that sounded like bad news. But from Philippe Gross, I learned that since there's so many antibiotic-resistant bacteria, the prescription that I get probably wouldn't work anyway, so it doesn't really matter. So we got off to a cheery start. Then we talked about 17 million people dying per year. This is serious stuff. 30% of the deaths in the world are caused by infectious disease. Of course, we're all worried about pandemic diseases coming out of tropical parts of the world. We are worried about antibiotic resistance. And even Rex Morgan, MD, is worried about antibiotic resistance, as I learned recently. And also, Baggy Singh reminded us that in Canada, and I won't speak for our Californian friends, but in Canada we're very concerned about hospital infections and food safety. And so there are loads of motivations driving forward the agenda on infectious disease. We had a very spirited discussion. We defined a number of challenges, starting off with the challenge of the need for better diagnostics. And there you can sum that up as a need for what Scott Lane described as virtually real-time global surveillance, the ability to do rapid and large-scale screening for known and potentially emerging threats, pandemic threats and just good old-fashioned flu. And then Michel, getting back to the doctor giving me antibiotics that don't work, he's concerned, and along with Marc Madu, is concerned with what was called low resolution. I never was quite sure what high resolution and low resolution was. But low resolution diagnostics, point of care, something you hold in your hand, screen for dozens of potential diseases so you can prescribe the right treatment. We went on to look at other challenges, and so the diagnostics group also had written a white paper. They formed quite an interesting group which proposes to combine the low-resolution point-of-care diagnostics with this high-resolution, high-throughput global surveillance, basically so that each can inform the other and that we can do better tracking of infectious diseases as they emerge and as they spread. So important for public health, important for all sorts of reasons. We then also, of course, it's, as I think I said, that it's not really good news if you find out sooner what you're going to die of. It's important that we have proper treatments for these diseases. And so we talked about the challenge of things like vaccine development. How do you develop vaccines rapidly for emerging threats that you may not have known about last month, that you've identified because of this global surveillance? How do you respond to the threats that you do know about? How do you do a simple thing like make a flu vaccine more effective in a shorter period of time? Understanding the response of the human body to infectious diseases and multiple infectious diseases is important, and of course developing therapeutics. So these were the things that we talked about. We used the diagnostic group that had written the white paper as an exemplar of the sort of team that you can develop between California and Canada to really tackle a major problem. And it was identified as one of the major problems in infectious disease, not the only one. Finally, I think it's fair to say that the focus in general terms was on technology platforms and large-scale technologies that are now, if you're going to screen for sort of 10,000 pathogens simultaneously, it takes a huge facility to do that. There's no point in building one of these huge, well, even if you could afford to, you don't need to build one of these in every single university on Earth. And so this notion of collaborating, particularly when you get to very expensive facilities like level 3 and level 4 biocontainment facilities, when you talk about coordinating mouse models for infectious disease, when you talk about large-scale genomic and proteomic screening, all of these things require a consortium approach. And so we did discuss the complementary facilities in both Canada and California, the need to get together. And so we agreed, first of all, that the call for proposals that will be issued should be fairly broadly based and should look at the challenges of infectious disease in more general terms, because these are all very serious challenges and need to be addressed by the sort of model that has been put forward by the diagnostics group.
Okay. Why don't we go right now to the carbons capture and storage?
I have slides.
Okay.
Make the rest of us look bad, eh?
Wow. How did you get slides?
You were fast. Okay, now what do I do with this thing? Okay, before I even start, let me introduce myself quickly. I'm Arthur Lee with Chevron Corporation. I'm a principal advisor on environment and climate change based in San Ramon, California. My job at the company is, a lot of the role is to look after the, F5, right? Is to look after the climate change issues in various aspects, including technology, the technology deployment issues. So I'm very happy to be here to sort of be the workshop, more or less be the fall guy, if you will, to represent our workshop, our roundtable discussion. But I do want to recognize several people before I say anything else. Certainly recognize Lisa Stockley for keeping us honest, Lisa from the Canadian Consulate, Bill Rainin of Canada, Larry Meyer of California, whom the two of them I roped in immediately to do this roundtable discussion to help organize it, and also Deborah Walsh from Chevron Canada, who's been very helpful in providing some of the other resources, and Gemma Hedl, who works on my staff, and Mike Gentry, who's with Chevron Energy Technology Company. So those are the people who organized the whole roundtable discussion today. So let me just get right to it. The theme of our discussion is the overall theme is pathways to widespread deployment. The reason we chose that theme is because carbon capture and geologic storage as a set of technologies, if you will, have actually been around quite a long time. It's been around for decades, if you will. I could even say safely over 30, almost 40 years.